Welcome to Joy of Architecture. Today, we're going to get into something really fascinating that's happening online, specifically how AI agents are starting to pop up everywhere in e-commerce.
That's right. It feels like a real shift is underway. We've been looking into how these agents could fundamentally change, the whole online shopping experience, making it way smarter.
Exactly. So we want to break down some of the key ideas behind this today, give you a clear picture of the tech and the architectures making it happen.
Yeah, absolutely. So first up, we should probably talk about just how fast the internet's changing with AI, and especially these agents.
Right. And maybe touch on some specific e-commerce use cases. What could they actually do?
Definitely. Then we need to tackle the big buzzword, MCP, Model Context Protocol.
Ah, yes, MCP. Everyone's talking about it. Why is it such a big deal, particularly, in the world of microservices?
We'll get into that. It solves a pretty fundamental problem, and we'll look at how major tech like Python, Spring Boot, Node.js, even Apollo GraphQL, how they've jumped on board really quickly.
Okay. And then there's Google's role in all this. Their AI stack, the Agent Development Kit, ADK.
Yeah, Google's ADK is key here, especially how it uses MCP. And that leads us into building multi-agent systems with ADK.
Multi-agent systems. Okay, so different AIs working together. What kinds are there? How do they manage things like, memory and context in an e-commerce flow?
Exactly. We'll break down the different agent types, Elm agent, sequential agent, and so on, and their roles, and yeah, how they handle sessions and memory.
And then there's another Google thing, A2A, agent-to-agent protocol. How's that different from the ADK multi-agent stuff?
Good question. A2A is more about agents from different systems talking to each other. We'll cover that. Plus, how you actually deploy these things in production. Maybe even touch on Google Agent Space.
Okay, so ADK for building within a system, A2A for talking between systems. Got it. We'll need to understand the benefits of A2A too.
For sure. And we can even explore multimodal agents, like voice agents using A2A and MCP together. Imagine talking to a shopping assistant.
Voice agents. Interesting. And you mentioned going beyond MCP with something called RAG.
Right, Retrieval Augmented Generation.
Yeah.
RAG is super important for dealing with all the messy, unstructured stuff, PDFs, images, videos that e-commerce sites have. We'll talk embeddings, vector databases, the whole picture.
Wow, okay. So structured data via MCP, unstructured via RAG,
Mm-hmm.
and then finally, how do we tie it all together? Like a practical guide.
Yeah, exactly. We'll walk through how you could take, say, an existing microservices setup using Apollo GraphQL Federation, turn those services into MCP servers, and build agents for the whole user journey, browsing, cart, checkout, tracking.
Okay, a full agentic workflow. And maybe that customer support example, the voice agent handling a return.
Absolutely. We'll cover how a voice agent could use A2A, MCP, WebSockets for the live audio, and RAG to look up support info to handle something like a product return. It really brings all the pieces together.
Fantastic. Sounds like a packed deep dive. Let's get started. So this evolution of the internet with AI agents, it feels like it's happening fast.
It really is. AI applications are becoming more common, but agents are sort of the next step, these autonomous bits of software that can act on your behalf.
And in e-commerce, that seems huge. What are some concrete examples? You mentioned personalized shopping.
Yeah, think way beyond basic recommendations. An agent that really understands your style, your past buys, maybe even your budget, and proactively finds things for you, almost like a personal stylist.
Okay, I like the sound of that. What about customer service? That's often a pain point.
Oh, definitely. Agents are getting much better at handling common queries, order tracking, product questions, returns, instantly, 24/7. That frees up human agents for the really tricky stuff.
So faster answers, less waiting. Could they do more complex things too, like finding deals?
Potentially, yes. Imagine an agent that scours multiple sites to find the absolute best price for that specific TV you want, or maybe even negotiate slightly with a vendor's agent. That's further out, but possible.
Price negotiation by bots. Interesting.
And proactive notifications, too. Your agent telling you, hey, that jacket on your wish list is back in stock, or there's a special offer on running shoes, your size. Much more targeted than generic emails.
Right. Really personalized and timely.
Yeah.
Okay, so that sets the stage. Let's dive into this MCP thing, Model Context Protocol. You said it solves a fundamental problem, the NEM problem.
Exactly. The NESM integration problem. It's a classic headache. Imagine you've got MAI applications like your recommendation engine, fraud detector search tool. And they need data from N different tools or services, product database, inventory, payments.
Okay.
Traditionally, you might end up building a specific connection and integration between each AI app and each tool it needs. That's M times N connections. It gets incredibly complex, messy, and hard to maintain fast. Lots of repeated effort.
Yeah, I can picture that web of connections, a
Yeah.
nightmare. So MCP fixes this how?
By standardizing, it flips it to an M plus N problem. Instead of custom connections, the tool providers build MCP servers. These are like standardized front doors for their tools. Then the AI developers build MCP clients for their applications.
Okay.
And all these clients and servers talk using the same language, the Model Context Protocol. So you build N servers, M clients, and they can all communicate. Way simpler. Huge for reusability.
So it's like agreeing on a standard plug-in socket type. Everyone builds to that standard and things just connect.
That's a great analogy, yeah. It's a universal translator or a standard plug. It lets different AI agents and tools talk without needing custom adapters for every single pairing.
But what about existing APIs? Most e-commerce platforms run on REST or GraphQL already. Do they need to ditch all that?
No, not at all. And that's one of the really smart things about MCP. It works on top of existing protocols like REST or GraphQL. It's like an execution layer above them.
Oh.
You can essentially wrap your existing REST endpoint or your GraphQL service with an MCP server interface. So the underlying service doesn't change, but it now has this standard MCP hat on so agents can talk to it easily.
That's brilliant. It avoids a massive rewrite, makes adoption much easier.
Definitely. And you mentioned microservices earlier. MCP fits perfectly there. You've got all these independent services with their own APIs.
Right, a typical e-commerce backend.
MCP gives AI agents a standard way to talk to any of those microservices without needing to know the specific underlying API details of each one. It just talks MCP. That drastically simplifies integrating AI into those complex distributed systems.
Okay, that makes a lot of sense. And you said the tech world jumped on this fast. Python, Spring Boot, Node, Apollo.
Yeah, the adoption's been really quick. Python has SDKs now for building clients and servers. For Spring Boot, there are things like the Spring Boot Bridge MCP server to make it easy for Java folks. Node.js has libraries too, like the one from Snake Labs.
And Apollo GraphQL.
Yep. Apollo now has an Apollo MCP server offering. So if you're heavy into GraphQL Federation, you can expose those capabilities via MCP pretty readily. It just shows how much potential people see in this standard.
Okay, so MCP provides the standard communication layer. Now let's talk about Google's Stack and their agent development kit, ADK. How does that fit in? Does it just use MCP?
Pretty much. ADK is Google's framework for actually building the agents themselves. It gives you the tools, the structures, the components to create complex, intelligent agents. And yes, it's designed to work seamlessly with MCP.
So ADK is for building the agent's brain, and ACP is how that brain talks to the outside world, like those microservices we wrapped.
Exactly. ADK handles the agent's logic, its goals, its internal state. MCP provides the standardized way for that ADK-built agent to access external tools and data exposed via MCP servers.
Got it. And ADK is particularly geared towards these multi-agent systems, you said. What does that mean in practice? Is it just multiple agents running side by side?
It's a bit more structured than that. In ADK terms, a multi-agent system means you compose your application from multiple distinct base agent instances. Think of it like building a team of specialist AIs rather than one giant AI trying to do everything.
Okay, a team.
Yeah, each agent has a specific role. Maybe one handles user chat, another queries databases, another processes payments. They collaborate to achieve a bigger goal, like completing a purchase. This makes the whole system more modular, easier to manage, and you can reuse the specialists.
That sounds much more organized, especially for complex things like e-commerce. What kinds of specialist agents does ADK provide?
There are several core types. You've got the LM agent, which uses a large language model, great for natural conversation, understanding user requests, making recommendations.
Right, the chatty one.
Then there's the sequential agent. This one's for processes that have to happen in a strict order, like a checkout flow. Step 1, then step 2, then step 3.
Like a workflow engine. Makes sense. What else?
Parallel agent. This one can run multiple tasks at the same time. Super useful for things like searching multiple product sources simultaneously to get results faster.
Ah, for speed. Good.
There's also a loop agent for repetitive tasks, maybe checking stock levels periodically until an item is available, then firing off a notification.
Okay. And what if you need something really specific to your business?
That's where a custom agent comes in. You can build your own agent logic for specialized tasks, like applying complex discount rules or talking to an old legacy system.
Flexibility, nice. And you mentioned an agent tool.
Yeah, agent tool isn't really an agent itself, but it's how one agent can basically call another agent like a function. It lets them delegate specific tasks to each other.
Okay, let's try an example. Say I ask a chatbot, find me waterproof hiking boots under 150 pounds.
Yeah.
How would these agents work together?
All right. So your initial chat interaction would likely be with an Elm agent. It understands waterproof hiking boots under 150 pounds. It might then use an agent tool to call a parallel agent. This parallel agent simultaneously hits maybe 3 different product catalog APIs, which are now MCP servers. Remember, searching for boots matching the criteria?
Right, gets the raw data fast.
Exactly. The parallel agent gathers the results and passes them back to the Elm agent. The Elm agent might then filter them further, maybe check reviews or stock levels using other tools, and then presents the best options back to you in a natural way.
And if I choose a pair?
Then it might hand off to a sequential agent for the checkout process address, payment confirmation, each step in order. That payment step might even involve calling a specialized custom agent via an agent tool to handle the secure transaction.
Wow, okay, you can really see how they orchestrate things. And the reusability aspect, how does that work?
Well, that secure custom agent for payment processing, you might build it once, but it could be reused by the main checkout flow, maybe a quick reorder function, perhaps even in the returns process if you need to issue refunds.
Ah, I see. Build a specialist once, use it wherever needed, saves a lot of effort.
Precisely. Promotes consistency and efficiency.
Now, for any of this to work smoothly, the agents need to remember things, right? Like what's in my cart or who I am. How does ADK handle that context, the session in memory?
Good point. ADK has specific services for that. For short-term memory within a single conversation, there's the session service. It tracks the current state, what you just asked, what's in your cart right now.
The current interaction.
Yeah. And there are different ways to store that session data in memory session service for quick tests, at database session service to save it properly in production, or even Vertex A session service if you're using Google Cloud.
And for longer term stuff, like my past orders or preferences.
That's where the memory service comes in. This lets agents recall your purchase history, saved addresses, maybe even preferences you stated before. Again, there's an in-memory memory service for simple cases.
But what about more complex knowledge?
For that, especially if you want to use that REG technique we mentioned earlier to pull insights from unstructured data like old reviews or product docs, ADK integrates with Vertex AREG memory service. That allows the agent to access and reason over much richer long-term information.
Okay, so ADK provides the building blocks for agents and multi-agent systems within an application, managing their short-term and long-term memory. But you mentioned A2A for communication between different systems.
Exactly. Think of ADK multi-agent systems as building a well-coordinated team inside your own company's application. The agent-to-agent A2A protocol is more like setting up a standard way for your team to talk to teams in other companies or other completely separate systems. It's about broader interoperability.
Breaking down the walls between different agent systems. So before we get into A2A details, how do we deploy these ADK agents we've built? Can I just run them on my laptop?
You can run them locally for testing, sure, but for production, you typically containerize them using Docker. Then you can deploy those containers on platforms like Google Cloud Run for serverless execution or Google Kubernetes Engine, GKE, if you need more orchestration control.
Standard container deployments? What about Google Agent Space?
Right, Agent Space is Google's managed service specifically for deploying and scaling these ADK agents. It takes away a lot of the infrastructure management burden, so you can focus more on the agent logic itself. It's another option, particularly if you want a more PASI-like experience.
Okay, multiple deployment choices. Now let's dive into A2A. What are the core ideas behind this protocol? How does it enable agents from different places to talk?
A2A tackles a few key things. First, how do agents even find each other? It standardizes the concept of agent cards. Think of them like digital business cards for agents.
Agent cards, okay. What's on them?
They contain key info: where the agent lives, its service URL, how to talk to it, which A2A communication methods it supports, like request response or streaming, how to authenticate, what security method it needs, like an API key or OAuth 2, and crucially, what it can do.
It's skills.
Exactly. The card describes the agent's capabilities or skills, detailing the tasks it can perform, the input it expects, and the output it provides. These cards can be hosted at standard web addresses or listed in registries so other agents can discover them.
So discovery and capability description. Once Agent A finds Agent B's card and wants to use a skill, how do they actually communicate?
A2A defines the communication building blocks. You have tasks, which represent the job Agent A wants Agent B to do. Communication happens through messages, which contain parts. A part could be text, a file, or structured data like JSON, and the result Agent B produces is called an artifact.
Tasks, messages, parts, artifacts.
Yeah.
Are there different ways they can talk back and forth?
Yes, A2A supports a few interaction patterns. The basic one is simple. Request response, ask a question, get an answer. For longer conversations or updates, it supports streaming via server-sent events. And for getting notified about events later, it supports push notifications using webhooks.
Flexible communication and security.
A2A delegates that. It relies on standard web security mechanisms advertised in the agent card, things like bearer tokens, API keys and headers, OAuth 2. The card tells you how to authenticate.
Okay, so how would this A2A actually be useful in a real e-commerce scenario? Give us some examples connecting different systems.
Sure. Imagine your e-commerce store uses a third-party company for warehousing and shipping, a 3PL. Your order processing agent, built with ADK maybe, could use A2A to talk directly to the 3PL's inventory agent. When an order comes in, your agent sends an A2A task. Reserve item X, ship to this address. The 3PL agent responds via A2A with confirmation and later, maybe tracking info via a push notification.
Okay, connecting to partners seamlessly. What else?
Or a price comparison site. Its agent could use A2A to discover the product catalog agents of several different retailers. It sends A2A tasks asking for the price and stock of a specific TV, gathers the artifacts, the prices, and shows the user the best deal.
Right, aggregating data from competitors.
One more, customer support. Your main chatbot agent handles simple stuff. But if a customer asks about a complex warranty return, the chatbot could use A2A to find and delegate the task to a specialized warranty returns agent in another department, passing along all the chat history.
Smooth handoffs. That really shows the potential for connecting disparate systems. Now, you mentioned multimodal agents earlier. What are they and how could one work with A2A and MCP, like a voice agent?
Multimodal just means the agent can handle more than just text. Voice, images, video, input, and output. So yeah, picture a voice agent you talk to on your phone or smart speaker to shop.
Okay.
You say, I want to return the blue sweater I bought last week. The voice agent might first use MCP to securely access your order history microservice to find that specific order.
Right, using the internal standard.
Then, to actually process the return, it might use A2A. It discovers the returns processing agent, maybe run by a different team, sends it a task via A2A containing the order details and your request.
Okay, talking to the specialist agent.
The returns agent does its thing and responds via A2A, maybe with return instructions and a shipping label file as an artifact. The voice agent receives this, translates the instructions back into speech for you, and maybe emails you the label file.
Very cool. Voice interface using MCP for internal data and A2A for external or specialized tasks. Okay, so MCP handles structured API access, A2A handles interagent communication. But what about all the other information e-commerce sites have? PDFs, manuals, reviews. That's where RAG comes in.
Precisely. Retrieval Augmented Generation, RAG. It's a technique to make LLMs smarter by letting them look things up in external documents before they answer. It grounds their responses in real data, making them more accurate and factual.
Give me an e-commerce example where plain MCP APIs wouldn't cut it, but a RAG would help.
Okay. Imagine a customer asks your chatbot, is the specific red dye used in this organic cotton t-shirt compliant with OCO Text Standard 100 certification? Your standard product API, exposed via MCP, probably just says organic cotton, maybe red. It won't have that level of dye certification detail.
Right, that info is probably buried in some PDF certification document somewhere.
Exactly. That's unstructured data. RG is designed for this. E-commerce sites have tons of it. PDF manuals, safety docs, warranty details, long text reviews, even details mentioned in product demo videos. RG lets the AI tap into all of that.
What's the magic? You mentioned embeddings and vector databases.
Yeah. So first, you take all those unstructured documents, PDFs, text snippets, maybe even transcripts of videos, and you process them. You create embeddings for chunks of text. An embedding is like a numerical fingerprint that captures the semantic meaning of the text.
Okay, numbers representing meaning.
Then you store all these embeddings in a special database called a vector database. This database is really good at finding embeddings that are similar in meaning, even if they don't use the exact same words.
So back to the t-shirt dye question.
Right. The RAG system takes the customer's question, is the red dye OECO text compliant, creates an embedding for it, and then searches the vector database for document chunks with the most similar embeddings. It might find paragraphs from the OECO text certification PDF or a supplier's technical spec sheet that talk about the dyes used.
It finds the relevant bits of text.
Yes. Then it takes those relevant text snippets and feeds them to the LLM along with the original question. It basically says, okay, LLM, answer this question, and here's some relevant information I found in these documents to help you. The LLM then generates a much more informed, accurate answer based on that retrieved context.
That is incredibly powerful. It unlocks all that hidden knowledge. Okay, this is all amazing tech. Let's bring it down to earth. How would you implement this? Say I have an e-commerce site already running on microservices using Apollo GraphQL Federation. How do I build an agentic network on top?
Okay, practical steps. First, you need to make your existing services agent-friendly. You take your existing GraphQL capabilities, product catalog, cart, orders, shipping, and you wrap them to expose them as MCP servers.
Using something like that Apollo MCP server tool.
Exactly. You're essentially putting that standard MCP interface on top of your GraphQL endpoints. Now, AI agents can talk to your core services using the standard protocol.
Step 1. Expose existing services via MCP. What's next?
Step 2. Build the agents. Using a framework like ADK, you start creating the agents that will actually use those MCP servers. You'd build an agent for browsing products, querying the product catalog MCP server, an agent for managing the cart, talking to the cart MCP server, an agent for checkout, using the order MCP server, and maybe one for tracking, hitting the shipping MCP server.
So, building the functional agents that interact with the newly MCP-enabled backend.
Right. Now you have the basic agentic user flow. Step 3 is to make it smarter using multi-agent and A2A concepts.
Okay.
Maybe your product browsing agent isn't great at recommendations, so you build a specialized recommendation agent. It uses MCP to get user history, but then maybe uses A2A to talk to a separate marketing agent to pull relevant promotions before suggesting products back to the browsing agent.
Huh. Agents collaborating using A2A.
Or, for security, your main checkout agent, using ADK and MCP, doesn't handle payment details directly. It uses A2A to delegate the payment task to a separate, highly secure payment processing agent. It creates a network of specialized, interoperable agents.
That sounds much more robust and scalable. Okay, one last practical example. The customer support voice agent handling a return. Walk me through that using all these pieces.
All right, customer call support. A telephony provider connects the call to your support voice agent. They establish a real-time audio stream, probably using WebSockets, between the customer and the agent.
Okay, live audio connection.
As the customer explains they want to return a faulty product, the agent is converting speech to text in real time. Simultaneously, it's using RAG. It takes the customer's utterances, embeds them, and queries its vector database containing support articles, return policies, product manuals, FAQs.
Searching for relevant info while listening.
Exactly. It retrieves relevant snippets about the return policy for that product or troubleshooting steps. It uses this RAG retrieve info, plus maybe data pulled via MCP about the customer's order, to converse intelligently, answer questions, and guide the customer.
What if it gets stuck or needs to actually initiate the return?
If the voice agent determines it needs to start the formal return process or escalate to a human, it uses A2A. It finds the appropriate specialized agent, like a returns initiation agent, or maybe a human agent's task queue. It sends an A2A task containing all the context, customer ID, order info, summary of the issue, steps already tried, so the next agent or person has everything they need.
Seamless handoff using A2A, powered by RAG and MCP behind the scenes. That really connects everything.
It does. You see how MCP provides the basic plumbing for service access, RB unlocks unstructured knowledge, ADK helps build sophisticated agent logic, and A2A enables collaboration across different systems and specialists.
Wow. We've covered a lot today: the rise of agents, the importance of MCP for standardizing API access, Google's ADK for building these agent teams, A2A for making them talk across systems, and RB for tapping into deeper knowledge.
It really feels like MCP and A2A in particular are becoming foundational. They're the protocols that could underpin a much more interconnected and intelligent future for e-commerce, and probably well beyond it too.
Absolutely. The potential here is just huge. This has been a truly fascinating deep dive. I hope you all listening found that as insightful as I did.
Yeah, it's an exciting space to watch right now. Things are moving incredibly fast.
They certainly are. Well, if you want to keep up with the latest in software architecture and AI, definitely subscribe to the show for more deep dives like this one. Thanks for joining us on Joy of Architecture.